All right, guys. So for today, thanks. So for today, we are graphing linear inequalities. So, guys, what do you think of when you think of inequalities? What symbols? What? Do inequalities have equal signs? No. So what kind of signs do they have? The greater than, less than, or the equal to parts. Good. So that's what we're looking at. So first, let's just kind of start with making sure you know how they kind of work. So tell whether the given ordered pair is a solution of 5x minus 2y less than or equal to 6. So this is like 4 separate problems, right? It's asking, is it a solution to this? So first thing we want to do, remember these are x and then y. We want to plug them into this and see if it works. So 5 times 0 minus 2 times the y, is that less than or equal to 6? That's what it's asking. So if you plug it in, does it work or not? So 5 times 0 is 0, and then negative 2 and negative 4 is 8, so I have 8. Is that less than or equal to 6? No. So that one is not an answer. That does not work. Okay, what about 2, 2? So again, we're just going to plug them in, right? So 5 times 2 minus 2 times 2, is that less than or equal to 6? So 5 times 2 is 10. That gives me 4. What's 10 minus 4? Is that less than or equal to 6? Yes, it is. So that one is an answer. That's a good one. All right, what about negative 3, 8? So 5 times negative 3 minus 2 times 8, less than or equal to 6. So that's negative 15 minus 16. That gives me negative 31. Is that less than or equal to 6? Yeah. And the last one. 5 times negative 1 minus 2 times negative 7, less than or equal to 6. So that's negative 5 plus 14. That gives me 9, less than or equal to 6? No, that one's not. Pay attention. All right, so out of those 4, only 2 of them were answers. Questions on that, just how to tell whether or not the answer worked. Good, I plugged in x and y. See if it works. Okay. No, I truly understand. That's all I did, is I plugged in x and y and I saw if it worked. That's all I did. All right, so the next part of this, if you are graphing the inequality, so we graph similar than we do for regular equations, but a few things change. Okay, so you can solve these in any method you like. So we can do the XY table, plug in values. You can find your intercepts. Most people probably go slope-intercept form. It's typically the easiest. All right, when you are graphing them, if it has a greater than or a less than, no equal to part under it, you're going to use a dotted line when you graph that. So instead of just drawing a regular line on that graph, it's a dotted or a dashed line. If it has the equal to part, you are going to use a solid line. Then you can just do it like normal. Now, do you guys know why you do that? Like the thing we were just looking at, if you ended up with 6 is less than 6, let's say I didn't have the equal to under it, would that be true? No, because I can't include the 6, right? So a dotted line means anything on that line actually doesn't work. You can't use anything. You can get as close to that line as possible, right? Like I could use like 5.9999999, right? It's not 6, and that would work. That would be less than 6 here. So it says I can get as close as possible, but I cannot actually use what's on the line. Whereas if I had 6 is less than or equal to 6, I can use it. So anything on a solid line, I can use any of those values. Dotted, cannot use if it's on the line. Solid, you can. Luke, up here. All right, and then inequalities are talking about a big range of numbers, right? Like if I ask you what number is less than 6, it doesn't have just one answer, right? It's got anything less than that. It goes on forever. Would that include decimals and fractions? And yeah, anything. Okay, so what we do is we shade. So if there is a greater than or equal, we shade above the line, which hopefully makes sense, right? If it's greater than, we're shading above the line. So if I am looking at less than, ooh, my sign came off, or less than or equal to, you're going to shade below the line. Barely. All right, so the difference here between our other graphing that we did, we have to pay attention if it's a solid line or a dashed line or dotted line, and you have to pay attention to where you need to shade, because you're going to shade in saying everything that I'm shading in, these are all answers that work. Anything that's not shaded is not an answer. So let's go ahead and try some of these. So first let's practice the shading before we actually get into graphing. So if it was y is greater than whatever, and this is what your line looked like, which way is above that line? So notice it says y is greater than. So think of your y-axis. Where on the y-axis is it above the line that you drew? That's the side you want to shade. So you would just go ahead, you can shade it in. Usually people kind of scribble it in like that, and just anything over there is an answer. So what that means, like if I would be like, okay, so then tell me an answer that works. You could pick literally any ordered pair in the shaded area, and it'll work. Like the 4 that we tried to start with, right? I gave you 4 of them, so which one of these work? Any ordered pair in the shaded area will be an answer that would work. Anything that's not shaded, those are all answers that will not work. Okay, Dylan, are you with me? All right, so how about y is less than or equal? So it's below, but where's below? Right? Again, look at your y-axis. Is this below it? Is this below it? Yes, so I will shade down here. So you just kind of shade below that line. For whatever reason, there's always a handful of students that can't tell me what's above and what's below. Some of them struggle with that. Well, you know, in the angles of those lines, sometimes they're like, I don't know which one's above. Some people pick it up, no big deal. So y is greater than. Notice it is a dotted line because there's no line underneath there. So y is greater than. So again, where on the x or the y-axis, right? Because it says y. Good, on the right side of it, right? Because these numbers up here are above that line, so it's anything up here. So I could pick any ordered pair in here, and it would be a good answer. Could I pick one on the line? No, it's dotted, so we couldn't pick one on. And then y is less than. That is below. So again, we would be shading everything down below here. So your shading doesn't have to be pretty, just enough so I can tell which side you're talking about. So okay, let's go ahead and practice graphing, shading, dotted line, solid line, whatever it is. So yes, if you want to use the slope-intercept method, which is usually probably the easiest, we would just solve for y first. So let's go ahead and subtract the 5x to the other side. So negative 2y less than or equal. When I move the 5x, becomes minus 5x minus 4y, or I'm sorry, minus 4. Then to get y by itself, we have to divide. Very good. Dividing by a negative, so that less than or equal to flips to a greater than or equal to. Negative 5x over negative 2. What's that? Don't change it to a decimal, guys. We want 5 over 2. Because remember, that's our slope, right? So we want rise over run. We want a fraction. And that would be plus 2. Good. So graphing, some of us are still struggling here. What's the first point you make? It'd be at 2 on the y-axis, right? Because that's your starting point. No. Your slope is rise over run. So I need to go up 5 and over 2. From that point you already made, go up 5 and then over 2. If I wanted another point, what else could I do? I could go down 5 and back 2. Oops, not enough. There you go. Is this going to be a solid line or a dotted line? Solid. It's got the line. It's got this line under it, right? So we know it's going to be solid. Not bad. And now I need to shade, above or below. Since my answer here was greater than or equal to, it means I shade above. Again, if you're not sure, look at your y-axis. Where is the y-axis above the line? And it would be up here. So then I would just shade in this whole area. So if I would ask you, Darian, give me 1 point that would work. Yeah, -2, 2 would work, right? Think about -2, 2. That point is in my shaded area. That's an answer that would work. Anything on that side. Yep. So you will have a couple questions on the quiz that you guys will take eventually for test that I'll ask you that. Tell me an answer that works. Okay? So you'll just have to pick an ordered pair in your shaded area. All right, number 2. Y is greater than -2x. Do I need to move anything? No, I like that. I don't have to move anything. Where's your starting point? 0. Good, because there is no number. So I'm going to start at 0. -2 over 1. It has to be rise over run. So from here, I'm going to go down 2 and over 1. Or I could go up 2 and back 1. Now, some of you have a tendency to go the wrong direction, or you go down and back. So if your slope is negative, which way should your line go? Uphill or downhill? Should go downhill, right? From left to right. We read from left to right. Make sure it's going down. Some of you did that on the activity that we did earlier this week. Solid line or dotted? Solid or dotted? Dotted, right? There's no equal underneath there. So a dotted or a dashed line. If you put solid, it's wrong. I know we're such in the habit of always just drawing a solid line. Make sure you have arrows on the ends of your line. And then where did we shade? Above. That is a greater than, so we shade above. So that whole area over there should be shaded. Toby, give me 1 point that would be an answer. 2, 2 works. Right? If you look at the point 2, 2, yep, that's somewhere above that line. It's in the shaded area. That works. Y is greater than or equal to -2/3 x minus 4. Do I need to move anything? Darian's like, I want to clear my fraction. Do you want to clear the fraction? We actually don't want to. Good. This one's already in the right form, so I wouldn't change anything. I would start at -4. So I'm going to go down 4 to start. It's my first point. Now that negative is kind of just sitting in front of the fraction. Where would you like to put it? On the top? Sure. So I can think of that as the negative up on top. You can put it on the bottom if you want, but don't put it top and bottom, because top and bottom makes it positive. So from here, I'm going to go down 2 and then to the right 3. Down 2 to the right 3. Or you could have went up 2 and then to the left 3. Either way is fine. Is it solid or dotted? Solid, good, because it's got the equal to part. And then do we shade above or below? Above. It's greater than, which means I shade above. Dylan, give me 1 point that's an answer. What? 2, 2. He's sticking with the 2, 2. Yes, that works. 2, 2. Is it pink? How are we feeling so far? Doing okay? All right. 3x minus 2y is less than -8. What should we do first? Good. Let's minus the 3x. So -2y is less than -3x minus 8. Then what would we do? Good. Divide by -2. Good. I'm going to have to switch that inequality sign, right? Instead of a less than, that would flip to a greater than, because I divided by a negative number. That's why it flipped. So -3x over -2. What would you write? 3 over 2, and change that to positive. And then negative 8 over negative 2 plus 4. Good. This is a time where fractions really shouldn't bother you because the fraction is a rise over run. Those fractions make it easy. So your first point goes at 4. And from there, we're going to go up 3 and over 2. Or you could go down 3 and back 2. Is it solid or dotted? Dotted. Good. There's no line underneath there. And are you shading above or below? Above. So anywhere in there. Luke, can you give me 1 point? Luke Wells. 1 point that was as an answer. Negative 2, 2. Is that on that side of that line? Yeah, it is. Just barely. Just barely, but it is. We're trying to stick with those 2's, I see. All right, why don't you guys go ahead and try this one? Actually, hold on, I take that back. Don't try this one yet. No, this one's a little harder. Plus what? Good. Let's plus the x to the other side. We plus it just to annoy Dylan. Add the x to the other side, so x plus 11. Divide by 3. Do I have to flip the inequality? No, I divided by a positive 3, so it's going to stay less than. Now, let's talk real quick as we're writing through this. How do I write x over 3? Good. 1 over 3x. 11 over 3. Now, say that again. 3 2/3. I love how Christian pointed at you like, that's what I was going to say. Now, guys, I'm glad that they figured that out, but why do we want to switch to 3 2/3 instead of 11/3? Christian? He just keeps like overshadowing. What did you say, Christian? Good, that's my starting point. Where the heck is 11/3 on a line? Heck if I know. Now, do you know where 3 2/3 roughly is? Yeah. I can go over to 3 and then up about 2/3 of the way. But if I would say 3 2/3, you're like, yeah, that's between 3 and 4. But if I say 11/3, you're like, I don't know. It is. But it's just easier to know where it is if you switch that. All right, so from there, I'm going to go up 1 and over 3. Remember, when I'm going up 1, I'm still at that in-between kind of part, right? So up 1 and then over 3. Up 1 over 3. Are we solid or are we dotted? Dotted. We are dotted. Oh, that one was really curvy. Sorry. And are we shading above or below? Below. Dylan, you got it? Good. Negative 2, negative 2. That works. Could we have went with your 2, 2? You could have went with this 2, 2. You could have had all of your 2's because they're all good. They're all in that shaded area. Sorry. I didn't know you were going to go with a span of 2's. Making this too easy. Don't you want to minus it just to annoy Dylan? Yeah. Oh, it cracks me up. Sorry. No, I would subtract the 7x over there. No different than the other problem, but I have a like term over here. So negative 4y greater than or equal. Since those are like terms, put them together. We're going to get 2x. All right, then what? Divided by negative 4. Very good. I'm going to switch that sign because I divided by a negative. So instead of greater than, it's going to be less than or equal to. Negative 1/2 x plus 2. Oh, look at all those 2's, you guys. Yeah, but make sure you're always simplifying. Some of you have a tendency to not simplify very good. All right, so my starting point, 2. I'm going to go up 2. From there, down 1, right or left? Right, good. Down 1 to the right 2. Or up 1 and to the left 2. Either way. Are we solid or dotted? Solid. Are we shading above or below? Below. Be careful. Make sure you're looking at your final answer because we flipped that. So it's going to be below. Good. Your negative 2, 2 works. Your negative 2, negative 2 works. 2, negative 2. How about 2, 2? No, that one didn't. Me personally, I see something like that. I'm like, yeah, the origin, 0, 0. That one works. Do I have to move anything? How do I graph this? Do I have an X? Good. Put the dot at negative 3 on the y-axis. Go down to negative 3. Which way does it go? No, no, no. Nope. Nope. Notice you have no x. So this is like saying 0x minus 3. If that helps, write it in. That's like 0x minus 3. So in other words, yeah, I'm going to rise 0 but run 1. Right? Rise 0 and run 1. So it's just going to be your horizontal line. Guys, if you only have an x or a y, right, I have one or the other, it's not an angled line. It's either straight up and down or it's horizontal. Shading above or, oh, I'm sorry, solid or dotted? Solid. Above or below? Oh, we're below, you guys. Where's your 2's at? Hey, we could go 2, negative 6 would work, right? 2, could I go 2, negative? Does that work? Sure does. I don't care. Negative 22, negative 22. If you want all your 2's in there, totally works. What if it's x is less than 2? Here's your 2 again. It's vertical. Yeah, so you're going to go to 2 on the x-axis, and it's going to be vertical. Dotted or solid? That one's dotted. Now, I normally say above or below, left or right. Where are the numbers less than 2 on the x-axis? They're to the left, right? Where are the numbers less than 2 on the x-axis? They're this way. So it's anything over here. I could go negative 2, 2, or negative 2, negative 2, if you want your 2's in there. I could say the origin, 0, 0. What about 2, 0? Does the point 2, 0 work? It's on the line. If it's on the line when it's dotted, it does not work. (3y plus 8x is greater than or equal to negative 18. Do this one on your own. All right, guys. So hopefully you move the 8x first. So 3y is greater than or equal to negative 8x minus 18. Divide by 3. Do I need to flip the inequality? Nope, I divided by a positive. So we have negative 8/3 x. That'd be minus 6. So your first point should have been at negative 6. And then from there, you would have went down 8's kind of not an option. So I'm going to go up 8 and then back 3. Up 8 and back 3. You all right? And then solid or dotted? Solid or dotted? Is that one off by one? No, it's all right. All right, so solid line. You could have. And then Above or below? Above. It's greater than. So again, the values of y that are greater are up here. So it's going to be anywhere on this side. 2, 2 would work. All right. Last problem. Oh my. We actually have words. Everybody panics, right? Just a little sneak peek into the next chapter. Chapter 3, we're still going to be dealing with graphs and things like that, but we're going to be writing equations, and we'll have a whole section of like story problems. So just kind of a sneak peek into it with what we got going on. So you have 2 part-time jobs. One pays $9 an hour, and the other pays $12 per hour. You would like to earn at least $240 per week. So just for a minute, forget X, forget Y, forget all of that stuff. How would you figure out how much money you would make if you're working at a job? You would take how much you make per hour and do what with it? You'd multiply it by how many hours you worked, right? And then what would you do? You take the money you made from one job and the money from the other job and do what with it? You'd add them together. And if it says at least, it means I want $240 or more. All right. You pretty much just answered this whole question. You guys realize that? Me asking those questions. So I would want from one job and the other job, so let's go 9x plus 12y. Doesn't matter which one's x, which one's y. It doesn't really matter. You're going to get the same answer either way. But I would take how much I'm making from each job, right? You'd multiply it, then you'd add those two things together, and I want it to be greater than or equal to 240. All right. So write and graph an inequality describing the possible amounts of time you can schedule at both jobs. List 3 possible answers. So let's go ahead and, we wrote it. Now let's go ahead and solve it and then graph it. So we'll go 12y greater than or equal to negative 9x plus 240. Divide by 12. So y is greater than or equal. Negative 9/12 would simplify to what? Good. Negative 3/4 x. And 240 divided by 12. Not 12. It'd be 20. Now, my grid. Look at you. Is it the second quadrant, though? It starts at the positive one here. 1, 2, 3, 4. That's quadrant 1. Okay, we haven't gone over that, but I'm impressed that you knew that there were quadrants. They were numbered. So do I actually need the other quadrants? Do I need any of the negatives? No, because I'm making money and it's not negatives. So really, I can graph this as in this is just my entire graph, right? Here's my y-axis, and here's my x-axis. So my starting point would be at 20. How many boxes are there? 20. There's 20. So my first point is actually going to be way up here at the top. And from there, go down 3 and over 4. Down 3, over 4. Solid or dotted? Solid. Above or below? Greater than. So anything up in there. So it wanted me to list 3 possible answers. So in other words, find an ordered pair that's in your shaded spot. Somebody give me one. Okay, 19, 19. Is that going to be in the shaded? Yeah. So I could work 19 hours at one job and 19 hours at the other job. It's going to be greater than or equal to 240. 20, 20. Now I'm going to change you a little bit. What if I wanted to make exactly 240? It's just not hard. I can find that answer just by looking at my graph. Today is your day. Man, he's right. Give me a point that's right on the line. You said 20. Is my line there? 1, 2, 3, 4. Yeah, my line got off just a little bit right there. So yeah, I could go 20 and 1, 2, 3, 4, 5. So if I go 20 zeros right here, which is not going to work. But if I went 25, it's right on the line. 0, 20 would work as well. Yep, 0, 20 would work. But yeah, if it's on the line, that's going to give you exact. Okay, anything in that shaded area is going to make me more than 240.